So in this video, we're going to use the secant method to solve for questions under numerical analysis. So now with the secant method, these formula can be somehow confusing, but I'm going to explain it in a way that you surely understand it. So let's take the formula. This is the formula for the secant method. So the secant method asks us, we are finding x at a specific value of I. So this xi, that is x, the subscript of I plus 1, is equal to xi minus the function value of xi, bracket open, times xi minus 1 all over the function value of xi minus the function value of xi minus 1. You see, this formula can be somewhat confusing, but with this video, I'm going to make it understand. So how do you go about it? Now, let's take a question to break it down. So this is a question given to us for us to find x when I is equal to 2. So this is the function given to us, right? So the function is s cubed minus 20, and they gave us our x naught to be 4. That's x0 to be 4 and x1 to be 5.5. Let's kindly note. Now, when solving this question, always note that the x with the highest subscript number represent the xi. Let me come again. The x with the highest subscript number represent the xi. So with this, which one will represent the xi is what? X1, because x1 is having the highest what? Subscript number. We couldn't take x0 or x0 because 1 is greater than 0. So x1 represents the xi in this case. So then we having our xi to be x1. We therefore try to prove the formula when I is equal to 2. So when I is equal to 2, and then we are finding it when I is equal to 2. So at I is equal to 2, that means that x subscript 2. So in this case, let's use this. We have our xi to be x1. So that will be 1 plus 1 is equal to x1, which is the same as xi, minus the function value of x1, bracket open, x1 minus 1, all over the function value of x1 minus the function value of x1 minus 1. So when you break the formula down, we are going to get that x2, in this case, the I value represents this, right? So it can be like you're also finding x2. It's the same as I2. Because at I2, depending on the initial point they give you, because here I made you aware that whenever they give you these 2 points, you must make sure that the x with the highest subscript represent the xi. Let's continue. So when we do that, we are going to get this. As simple as that. So we are going to get x1 minus the function value of x1, then bracket open, x1 minus x0. From here, 1 minus 1 is going to give you 0. So x0 all over the function value of x1 minus the function value of x0. So then let's take the function value. So when you take the function value, this is x0, we are going to get 44. And when you take x1, you're going to get what? 146.375. So then we are going to do just substitution. So let's just substitute into the equation to find our x2. That would mean that x1 is 5.5, bracket open, minus, that's 146.375 times x1 minus x0, because we've seen it here, x1 minus x0, all over 146.375 minus 44. And at the end, our x2 is going to give us 3.3553. The same applies to when you're finding x3. For you to find x3, what do? For x3, it means that we've gotten our x2 to be this. So then, therefore, we are not going to use x0. We are going to use x2 and x1. And in this case, when finding x2, that means that for when I is equal to 3, from here, it's going to be what? Because I told that when you are choosing, the xi is the highest, x with the highest subscript value. So then if you are finding maybe xi is equal to 3 or x3, that means you're going to take x2 and x1, right? And the highest one is what? X2. So you are going to take like x2 plus 1 is equal to x2 minus the function value of x2, bracket open, the x2 minus, this will be x2 minus 1, which will give you x1 here, all over the function value of x2 minus the function value of x0, x0. This is very simple. Just take the previous one. So if you are finding x3, this will be 2, this will be 2, this will be 2 minus 1, this will be 2, minus the function value of x1. So just the previous one. So we just take the previous one, work with it. Previous one, work with it, right? Yeah. So in this case, when you are finding the approximation error, that's the absolute approximation error. We are just going to take that x2 minus x1, whereby we have our x2 minus x1 all over x2 times 100%, and at the end you're going to get the value to be 63.92%. It's very simple as that. So you can try I3, whereby you get that will be x3 is equal to x2 minus the function value of x2 times x2 minus x1 all over the function value of x2 minus the function value of x1. So that's the same thing applies to when you're finding maybe x4 with x4 is equal to what? X3 minus the function value of x3 bracket open x3 minus x2 all over the function value of x3 minus the function value of x2. Thank you very much for watching this video.